Every once in a while, I run across an exceptional piece of shit. And this is one of those things, so here's a little video about it. This is a drop bracket that came with a lift kit. It's on a 1988 Bronco, and I don't know what the drop is on this, about 6 inches or so. Has the twin torsion beam in the front. This is the bracket that comes off of the frame. That was the original hole where the right front beam would mount to the frame. And this is the drop that drops it from there all the way down to here. The primary purpose of this, besides just dropping the height, is it's supposed to prevent the right front beam from moving side to side, mostly. And any forces that it takes in the side-to-side direction down here produce a rotation around this hole up here. And what's resisting it, partly that, but partly these two smaller bolts over here, which were, they might have been metric. They were pretty crusted up and threads were shot, but anyway, a little bit under 1/2 inch. So here's what we've done. This hole's okay. This hole's okay. But the way the bracket's designed, it's like 8-something inches tall, 6-ish inches between these two holes. But we only got about, I don't know, 3 inches or so, maybe less between these holes. So whatever torque you get here is actually multiplied by, yeah, almost a factor of 2. It is about a factor of 2. And the forces that you apply on these tiny bolts is just crazy. So that's problem number one. And you can see, I hope you can see, that these holes are all wallowed out from those forces being applied. We got big old ovals here and here, and it looks like that on the frame of the vehicle too. So now I got to drill these out, and I'm going to put in some oversized bolts up to about 1/2 inch to correct that problem. The other problem we got is how this piece of shit was manufactured. So just looking at the welds on this, it looks like it might have been machine welded. I don't think these were done by hand. I think that's machine welded with a MIG. I could be wrong, doesn't matter. Point is, I don't know what company made this, but this came out of a factory. This wasn't somebody's home fabrication, but here's how they did it. So this front section was a plate, welded down the side. Weld looks awesome, but they needed to bend it out right across here. There's one bend here, we got another bend here. Maybe you can see it better on that side. And to allow for that bend, they put a split in the material right there. That's not a crack. That's from the factory. That's intentional. They split it so they could bend it out. And that's the problem. You can't do that. Because what they've done, it would be bad enough if this thing were squared off. It never should have been squared off. Because as you're applying forces down here, and you're applying forces up here, ultimately what you're doing is you're putting a lot of stress across this corner, something like this direction, which tries to compress it and pull it apart right here in the corner. Even a hard corner is a bad idea. That's not the correct way to make this piece, because you have a stress concentration right here in the corner that will cause a crack to form and propagate. And on top of that, these assholes started the crack from the factory. They slit it right here so that they could produce the bend, and they left a slit. That is not a crack that has formed. You can see right here that slit is intentional. So they started a crack from the factory, which now, of course, has propagated up halfway through the piece. You can see it right about there. It's actually starting to fork, and it doesn't continue very much further, but about where this paint is rubbed off, all up into here, is probably the ends of the cracks. So now what I got to do to correct this, drill out the crack there, drill out the crack over here, take a cut-off wheel and slice all this stuff to get rid of all of the cracked area in between, bevel it out, fill it up with weld bead, and then because this does have to insert between the frame of the vehicle, I got to shave all this back down flat again. And to stop this from happening in the future, we're going to grind out that crack, fill it up, and I'm going to add a little bit of a fillet down here on the bottom, which will prevent it from cracking again. The other thing we're going to do to fix this is this never should have been taller than it is wide. It doesn't make sense for this to be, 6 inches and this to be 3. So what we're going to do is add another plate on this edge that extends over probably another 6 inches or so. There's a big flat section on the frame of the vehicle to work with where I can add more bracket. So I'm going to bring this over probably another 6+ inches with, I think that's 1/4 inch material. And we'll leave a fat weld bead up the back side where it won't hit anything. And then we'll put 2 more holes over here, which are also 1/2 inch. And then this thing will never move again. All right, we're all prepped up. Got the crack ground out good. Got the ends of it drilled out. It was a little bigger on the back side, so I hit it with an end mill. Dragged it out until it was all gone from both sides. Got a little valley in there I'm going to fill in. And I got the back side and front side both cleaned off best I can. This is a Millermatic 210. We're running 450, maybe a little higher because we're trying to fill a gap. But it's 1/4 inch, so we're going to stay on at least 4. Here we go. All right, first pass got almost full penetration on the back side, even filling all that hole. So now we're just going to hit it real hot, make sure we melt out all that crap. Put a good bead down the back side to fill all that in. And if we have leftover weld bead on the inside, that's totally fine. It doesn't hit anything in here and it's not in the way of the bolts. All right, we got a couple layers over what used to be the crack and hole. Looks like it's built up pretty good. I'm still going to add a little bit more on that corner for a fillet, but the back side looks okay to me. So here is the front surface after welding the crack shut and then hitting it with a flap wheel to smooth everything out. And it's got to be flat or slightly under because any bump will make it not fit into the frame. So I've taken it down to flat or just slightly under. And we got that nice fat fillet right here on the corner that's going to prevent that crack from coming back. That looks really good to me. That looks like a good repair, so that portion's done. Now we're going to drill these 2 holes out to accommodate bigger 1/2 inch bolts, and then we're going to add on more bracket. Now, since these holes are actually kind of ovals, I don't really trust a drill bit to go through it without catching, snapping, doing something weird, so I'm going to run a 1/2 inch end mill through it. I think that'll work better. I can lock the table down. I'm just eyeballing center on these holes. Their position's not that critical. And once this goes up into the vehicle's frame will get drilled out to match. So wherever it ends up is fine. I'm just going to get it close to centered on the hole and let the end mill go through. Okay, I don't know if you can tell if anything's been done to it, but those are 1/2 inch now. They were pretty close already since they'd been beat so badly. But they'll take a 1/2 inch bolt instead of 3/8 or 5/16 or whatever the hell was in there. I think it was 5/16 or metric. But it'll take 1/2 now. Okay, so here's my extension plate. It's been cut to the same height. I'm extending it out 4 inches. Hole pattern doesn't have to be the same, but it is about the same just for funsies. Some of you may notice that I've rounded this corner when I should have rounded just these 2 corners. To you I say, shut up. Rest looks pretty good. I left a good thick bead on there. And then remember that this outside has to sit, well, it sits vertically like this, kind of, down inside a channel of the frame. So this surface needs to be flat. So it's been ground flush again. And we got extended holes and we got the crack repaired. And we got them nice and rounded out. They're ready for 1/2 inch bolts. The rest of these were okay. And I think this piece is repaired and upgraded. And it's ready to go back in the truck tomorrow when it's daylight and I can see what I'm doing. It's the next day. We're putting the bracket back in. But before we do that, we're swapping out the bushing on that torsion beam arm. So once you get the old bushing off, the new one is supposed to press in. But, you know, good luck without taking this off and throwing it in a hydraulic press. So what I did is I made a custom puller for it. It's got a bearing race driver, a beat to shit one on the back side, and a bolt and washer and all that. And on this side, we put that, oh no, over a 5-inch bolt. Yeah, something like that. So what we'll do is we'll put a nut on this end, hold the bolt, pull this, and it's going to pull the bolt head and all that stuff on through until it sits flush. We'll see if it works. Well, the replacement bushing put up a good fight, but it's in there. There's the bracket in all its repaired glory, with bolts that run most of the way across the flat section of the frame.